From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
You build up a replica of your 3D printing robotic cell inside the software, and it doesn't matter if it's a ABB, KUKA, FANUC, Yaskawa robot, or it doesn't matter if it's a metal, concrete, or plastic material. You build it up, and we're robot and process agnostic. And then you drag and drop your CAD model into the software, and it's placed somewhere in front of the robot. And you have options to do certain operations on it and do path planning on it.
That's Emil Johansson. Emil is the CPO and co-founder of the French-Swedish startup ADAXIS. ADAXIS is building a software with the aim to revolutionize the manufacturing industry by making it effortless to use robotic arms as flexible 3D printers for plastics, composites, metals, and concrete parts. Their vision is to become the key enabler for a resilient and localized manufacturing ecosystem by combining robotics with modern process technologies. Emil has an extensive background with working with additive manufacturing at RISE Research Institute of Sweden. He has coordinated with national and international research projects with the main focus on development of new innovative 3D printing technologies. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, certification, qualification, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com.
All right, Emil, thank you so much for joining the show today. Excited for the conversation, kind of mixing a couple different genres of technologies with robotics and additive manufacturing today. So welcome to the show. And I like to start with some context about who I'm talking to, so I get to know you better and the audience as well. So where were you born? What were some of those early days like in terms of getting you on the path to where you are today?
Yeah, I was, first of all, thank you for having me on the podcast. It's a pleasure to be here. I'm a Swedish native. I was born in Jönköping in Sweden, and quite a small place outside of this place, actually. So I just grew up in a regular suburban neighborhood and had no idea that 3D printing existed for most of my life, to be honest. I started to become a chemical engineer, but it turns out that I am not very good at chemical engineering, and I'm not very passionate about reactor designs either. So I ended up looking for other chemistry-related opportunities and started working with 3D printing of technical ceramics. That is a very niche area. So 3D printing of zirconia and silicon nitride, super high performance materials with stereolithography. And I did that for a few years until at some point I discovered that a colleague of mine at Research Institutes of Sweden, where I was working, was doing these amazing things with robotics and trying to turn a gluing robot into a 3D printer. And that just excited me so much. And we managed to get research funding to do that, and we got to play around with it. So for a few years, I built up the capabilities of robotic printing with a ABB robot on a 6-meter track. So we could print, 20 cubic meters of massive parts, and did that for a few years until finally I discovered that to take robotic 3D printing into the future, we need to have more easy to use software. So I guess that's kind of the short version of how I ended up.
And I was curious, what do you define as a robot these days? I mean, everything has a computer in it, everything has a chip, right? Like your phone is super powerful, and like what in your mind when you say robot, what do you mean?
Well, we have a pretty narrow definition. When we talk about robots, it's actually industrial robots, so 6-axis robotic arms. But over the years, I've gotten to play around with mobile, like automated guided vehicles, basically, and putting robots on those, and other kinds of robots like, from Boston Dynamics and these kind of things. And the fantastic thing is that theoretically all of those could be a part in how you use 3D printing or manufacturing. But for us, it's 6-axis robots, and that's what we're trying to make easier.
So 6-axis means the kind of XYZ planes. It can spin, like it can turn,
and it can tilt. Yeah, exactly.
Okay, got it.
It's a typical thing that you would see if you think of a factory floor at an automotive company. You would probably have 800 robotic arms doing one thing. Like at Tesla, they have robotic arms to do all of the production. And what we saw, or what my colleague saw very early, was that you could basically take one of those and put a deposition unit at the end of it, and you can print with it.
Yeah. When I was over in Loughborough studying my PhD, I was in the Sports Technology Institute, and we had a FANUC 6-axis robot that, not me, but some of the other grad students there trained to hit a golf club. So
really?
You can all do all sorts of wild things with these.
So did it have like a vision system to detect a golf ball then?
I don't know enough of that. This is like 10 years ago, 10, 13 years ago, but
that's impressive. Yeah.
but yeah, go ahead.
Yeah, I have had a lot of these kind of really crazy, completely useless projects in mind. Like I would want to take an AGV, put a collaborative robot on an AGV. And the robotic vacuum cleaners, right? But I want to take an actual standard vacuum cleaner, put it into the hand of the robot on the AGV, and make what is probably the most ridiculously overpriced robotic vacuum cleaner in the world. Sadly, no one has really understood the beauty of that idea, and it's of course completely useless. But this is the kind of thing that I spend my time thinking about sometimes.
Well, you'll be glad to know that we're actively looking at a robo lawnmower for our backyard in the States. So, but anyways, like so you had some experience with additive manufacturing through your kind of composites, SLA, or kind of research work. Was that the first time that you had seen the technology, or had you seen it previously?
No, that was actually the first time, pretty much. So, I've always been, interested in the science part. But before I went to university, I was a photographer, actually, a news photographer for a while. And so 3D printing was not even on my radar. And then it was sort of like just serendipity that I found a master thesis in ceramic 3D printing. And that got me onto the path. So I had no idea what I wanted to do.
And with the kind of transit, like you see the technology, what was there anything that like kind of flipped a switch in your brain of like, hey, like this is actually like useful, right? Like, or like meaningful in terms of something that you wanted to kind of dive into more or kind of make your career out of?
Yeah, for me, it really opened my eyes for manufacturing overall. And at the time, this was 2015, there was really a resurgence of research into 3D printing overall in Sweden, because the government was starting to put a lot more funding into 3D printing to kind of make us catch up with Germany and the US and things like that. And so there were a lot of exciting things happening, and we got a lot of fantastic projects funded, in every kind of industry sector. So it really allowed me to get a very quick overview of where it could be deployed. So one thing that's very exciting about Siemens Energy in Sweden, for example, is that they are repairing burner tips for the gas turbines. And they've been doing that successfully as a production business case for many, many years now. And so it really opened my eyes to see that, okay, this is not just playing around, it's actually industrial. And if we put the right tools into the hands of the people who have the business cases, real magic can happen. And so, that's kind of what got me super passionate about the whole thing. And
And talk more about kind of what you're doing with combining robotics and additive manufacturing. Can you kind of walk us through what that looks like, both in terms of like business you're kind of building, as well as like the functionality of the part or the machines, the components and things that you're making?
Yeah, exactly. So I mean, 3D printing has been kind of limited in size for a long time, and I guess 10, 15 years ago, people started to just build bigger 3D printers. And in powder bed fusion, you just add more lasers and you add more powder, and that's the way you do it. But what gets really exciting is if you take infrastructure that already exists in the industry, for example, a robotic arm, of which there are like 3.5 million already in the world, right? And it's growing pretty fast. And then you can just put whatever you want at the end of it. So, we have companies printing chocolate and concrete and plastics and composites and metal and probably things that I haven't even figured out could be printed yet. And of course, then you have like people somewhere, and they have bought a secondhand robot and they put in their garage, and they're like, oh, we're going to print furniture or this and that. And you're kind of hit with a limit, which is 3D printing is quite a complex manufacturing process. And robots are arguably one of the more complicated things to program. And that's kind of where you get stuck, right? I mean, it's too difficult to program a robot. And to simplify it a little bit, robots haven't changed fundamentally in the way they look. I mean, 6-axis robots over the last 30 years. And software-wise, it's still very much built for experts, by experts, for experts. And I think the real magic happen for our customers is when you're kind of released from the constraints of the fact that you're using a robot. The robot is just there. You shouldn't have to think about it. So we have customers now in, railway, like the big railway companies, leading aerospace companies in Europe, and special effects companies in the US. And we're working in such a varied number of industries that I didn't even understand that this was possible with robotics and 3D printing, because it sounds like it's such a niche market, but it's growing super fast.
And why is it hard to program a robot? I could think of a couple reasons, but like in your eyes, like what makes that problem difficult? Because it's not like it's new, right? Like they've been
around for a while. I think fundamentally the robotic market has been for big companies. So I mean, if you're an automotive company, you're going to contact all the big robotic manufacturers and say, I need 800 robots. And by the way, can you please help me integrate them? And if you do that, we'll buy 800 robots. And so these companies, and maybe people in these companies, have not really thought too much about the programming and reprogramming of the robots, because either you have an automation integrator doing that, or the robotic company will help you if the order is big enough. And so the robotic knowledge has been with the integrators and experts. And that has worked for a long time. But the reason we saw a lot of collaborative robots being created, a collaborative robot is a robot which you can basically have it in the environment of a human, and if it touches you, it stops, right? And you can move it with your hand. That kind of revolutionized things, because anyone can then move the robot along a path and program it very easily. And I think it was quickly obvious that everyone has the need to use robots in manufacturing. And this kind of triggered a questioning, let's say, of why regular industrial robots should be so difficult. So there are many reasons why they're difficult. So while that's one, but also, every robotic company has their own programming language, and robots have singularities. So if they go into specific position, they don't know what to do. and they will just say, "Oh, I've reached the singularity. Unfortunately, I'm gonna stop moving now." So that's it. So there are a lot of like these weird things about robots, which are also like the beauty in my mind of the robot. But in my opinion, you shouldn't have to think about that, and you shouldn't have to learn a bunch of different extra programming languages to deal with it, in my opinion.
And is it also, how much of a factor is kind of coming off the pandemic and finding workforce in manufacturing is also difficult? Are more companies getting into robotics to see if it can be a solvable problem? Whereas like you have the bleeding edge of automotive or aerospace or defense where they're going to invest in it because they have the cash, right? And they're going to try and force fit it if they can, and they have more of a leeway. But is there any dynamics in the broader economy, at least here in the US, there's manufacturing workforce shortages all over the place.
Yeah.
So,
and that's super interesting actually. If you look at the numbers of the manufacturing companies in Europe, 20%, roughly speaking, are using robotics in their manufacturing. That's a lot, but I would have expected it to be more. If you look at the US, 10% are using robotics in manufacturing. So I think there is definitely a dynamic where you have shortages of labor and where robotics will play a part. And I think there's a tremendous potential for the vast majority of companies to introduce robotics in their manufacturing. So there's definitely potential there. And I think robots will play a bigger and bigger part in manufacturing, especially in smaller companies where they have not been so accessible until very recently.
Sure. And along those lines, do you want to like kind of walk us through maybe a case study or an example of the sort of work that you guys do with kind of combining additive and robotics? Like where were some of those early use cases that you guys found valuable to the market and the types of customers you're working with?
Yeah, so I mean, one of the very early customers is a small service provider in Sweden, which is called Sculpture, which were very early when it comes to robotic 3D printing. And I would say that they were and they still are at the very highest level when it comes to plastic printing of really large scale parts. So they had an ABB robot and they had it on a track, and they were printing for lots of different clients. And of course, I mean, if you're going to produce a variety of different parts, you're going to spend a lot of time programming the toolpaths for the robot. And so just a very early use case, we were just helping them be more efficient when it comes to programming the robot and generating toolpaths that were maybe not only planar, but also multi-axis, so that if you were printing something that was curved, you could follow the curve and have the layers evolve in a multi-planar or non-planar way throughout the part. So we did a lot of that in the very early days, and that was plastic, and it was biocomposite, and it was for furniture and tooling, like composites layup tooling. And then because my co-founders have experience with wire arc and wire laser on a robot, so 3D printing with metal, we also had a lot of interest from companies that were using welding, but they really wanted to start to 3D print with wire arc additive manufacturing. And then it becomes a completely different kind of application, of course. I mean, it's propeller blades, it's repair of parts for naval applications, it's aerospace applications, it's maybe landing gears for airplanes that are in titanium. So we don't really have a typical customer at the moment. It's all very varied, which is super exciting, but it also makes it difficult, right? Because we have to understand so many industries. But yeah, like a big part of it is just making the programming happen in 10 minutes instead of 10 days. And the other part is that we also enable real-time monitoring of these very complicated metal printing processes.
Awesome. And so say I have a turbine blade or something like that, and we want to use your process. So essentially, kind of the combination of software and hardware. I guess it's somewhat hardware agnostic, right? It's a robot of some form, but you kind of are working to make the transition from, okay, here's my CAD file to what the robot needs to do much more seamless. Is that a good understanding of like the actual
Yeah, exactly.
workflow?
So you build up a replica of your 3D printing robotic cell inside the software. And it doesn't matter if it's a ABB, KUKA, FANUC, Yaskawa robot, or it doesn't matter if it's a metal, concrete, or plastic material. You build it up, and we're robot and process agnostic. And then you drag and drop your CAD model into the software, and it's placed somewhere in front of the robot. And you have options to do certain operations on it and do path planning on it. And in many cases, with a few clicks of a button, you will get toolpaths that you can see immediately inside the software. The robot is moving, you understand the behavior of the printing of the robot, and you can easily export it so that you can run the program on the robot. And we're very committed to making this as easy as possible. I wouldn't say we're there yet. We still have a lot of work to do there. But we want it to be, you just connect to the robot, you press, configure, we auto-detect everything. And then you drag a CAD model into the software, and we figure out, without the user telling us what they want to do, we figure out what they want to do, and we generate everything. So this is like where we need to be, I think, to make this accessible.
Coming from a materials engineer, this is probably a biased question, but like where does the materials piece fit in? Is that because imagine you have different nozzles or heads based on what material you're using, right? Like where is that kind of interface that you guys work with in terms of the software?
Yeah, so we have libraries for everything. Like we have library for robots and linear tracks and 2-axis positioners for the placement of the part, and the printing heads and materials. So for materials, you can add your own materials, or you can use predefined materials. And we make intelligent decisions based on the material. But this is always a collaboration with the hardware supplier, because you have extruder suppliers and suppliers of 3D printing robot cells that are really good at what they do. And so we try to enable them to help their customers and have presets in the software for different materials for their process heads. And in welding, Fronius already have welding parameters for many different materials for their welding heads. And so we make it as easy as we can to select the right process settings.
And you mentioned it previously. A couple of the advantages that you have is like this different scale and the ability to reuse machines that already exist in the like manufacturing plants. But like, what from your customers are you hearing as kind of like, are there any unexpected benefits that you've heard kind of by taking this approach to kind of transforming an existing piece of hardware or kit and into an additional tool for repair or large part design?
Yeah, one is that there is a good second-hand market for robotic arms. So it is possible to find relatively cheap robotic arms. And the good thing is that robotic arms are also cheap to begin with, or relatively cheap. So if you
how much do they typically cost?
Well, if you want to get a robotic arm with, let's say, 3-meter reach, 2.5, 3-meter reach, maybe it's 60,000-70,000 euros, or in that region.
Mm-hmm.
I'm gonna get a lot of angry emails now, probably. But let's say in that region, sure. And then you need a printing head, and you need a bunch of other stuff. But in the end, it's not an unreasonable cost.
Yeah. I mean, a
As
single
long as-
DMLS, right, is $1 million, right? So
It's pretty, yeah, it can be pretty expensive. Of course, I mean, you're going to do different kinds of things with it.
sure.
But so it's not directly comparable, I guess. But yeah, that's one aspect of it. And the other is that you can put the robot anywhere, and it has a relatively small footprint. So I mean, if you don't have the warehouse to have a massive 3D printer, like a gantry style 3D printer, you might be able to have a robot in the corner.
Right.
And if you don't want it to take too much space, it just folds itself in. And you can put it close to a production line, or in a production line even, to print on things in the production line. And the most surprising thing that we've noticed is that when we say 3D printing, I'm thinking 3D printing of an Eiffel Tower or the Stanford Bunny or something fancy, like that. But 3D printing can also be just putting a couple of layers of material on a part, like an existing part, which you have a couple of hundreds of, and you just need to add a little bit of material, of some material somewhere. And it's 3 layers, and it's barely what anyone would call additive manufacturing, right? And it's not the exciting kind, maybe. But it's maybe even more beneficial in these use cases and these business cases. That's maybe the most surprising for me, is that the range of 3D printing applications become so big.
And talk a little bit about the company, like how many people are you now, and kind of is everything pretty much running out of kind of your location there?
Yeah, so we have a pretty interesting story. So we were launched in 2021, so it was the COVID pandemic, and we had met in a research project, and it was 2 French co-founders and 2 co-founders in Sweden. So we did a solid period at the beginning without even seeing each other for 9 months, something like that. I mean, we had met before, but we didn't see each other because of COVID. And that was very challenging, of course, but you become quickly very, very good at understanding people in a Teams meeting or over the phone or in writing. And that was very exciting as just a kind of twist of fate. But now we are headquartered in France. So I'm actually not in France. I'm sitting in Gothenburg together with our new Chief Marketing Officer, Ulf Linde, as well. And in France, we're 8 people, and here we're 2, and then we're 1 in the US and 1 in India at the moment. So we're kind of a semi-remote workforce. It's super exciting. We raised funding, I guess, a year and a half ago, something like that, and have been just pushing out software, building the product as quickly as we possibly can, and spending a lot of hours, in front of the laptop building the software, and that's super fun.
Fantastic. And what's on your radar for the rest of the year? What are you super excited about in terms of either the product or new features or new shows or new industries that you're launching into?
Yeah, I mean, there are 2 things that are super exciting for me right now. One is the real-time monitoring. So it's being able to connect to a robot, and then it magically connects and everything happens for you. But also monitoring of the process and making a lot of data accessible to operators that they can make informed decisions about. So we have spent the better part of this year actually developing the real-time monitoring system for ABB, KUKA, and FANUC, specifically for the metal additive industry, but it can also be applied to, plastic printing. And we get a lot of intelligence. We have early customers in that area which are using it every day when they're printing, and they use it for traceability, and that's, I think, going to be extremely useful for the future. The second part is that we are going to launch a milling module. So for specific things, you can combine very, very easily milling and additive in the same software, push it out to the robot, and it will print the part and mill it.
Would you have two different, how would that work? Would you have two different robots, or would you have two different end effectors, so to speak, for the same robot?
Well, I had a very interesting week. So yesterday we did a milling test at Rice, one of my, it was my previous employer as well. And they have now a robot where they changed the tool head to from an extruder to a milling spindle, and it's working really well. And I think that's one way to do it. And the other, of course, is if you have the capacity, you can have two robots. And you might even mill and print at the same time. So it's all very exciting. I think this is still a very early stage in exploring milling and additive with robotics, at least. And it could be super interesting, for big mold tools in composites, in metal tooling, propeller blades. A lot of things really opens up when you think about this, and that makes me super excited. And it got me back in the workshop as well, which is always nice.
Yeah, and just the potential to have it in a variety of ecosystems, right? Like if it's where people couldn't go, or they may not be able to work as long as a robot could. There could be some interesting applications.
Yeah, definitely. Yeah.
Awesome. And so are there any places that are you guys exhibiting at, like Formnext or any of the shows? I saw you kind of met some of the team in Rapid a few weeks ago, but are, like, for listeners, like, are there places where people could kind of go see some of the equipment that you've been building and see some of the use cases if they're interested?
Yeah, so we are going to exhibit at Formnext later this year. What we're going to do there is still a bit of a secret, but it's going to be super exciting. And we're always very excited to not only talk about ourselves, but also talk about the amazing hardware companies that exist in this space, because they are doing arguably the most interesting work. We are a software supplier. We try to make the programming easier. But of course, what's really exciting is to get the part out of a robot printer. And so we will definitely have an element of hardware at Formnext. I think that's going to be a very exciting show. And then, we'll be visiting a lot of places. In Berlin, we will be visiting, not as an exhibitor, but visiting, and that's, Formnext is the main one for us.
Fantastic.
Without a doubt.
Awesome. So last question, a little bit of a right turn here, but I'd like to ask some of the previous guests kind of what's a favorite book that made an impact on you throughout your career, kind of gave you some motivation or inspiration?
Yeah, this is a tricky question for me, because I have two answers to that. And one is going to reveal a side of me which I wasn't sure if I was going to talk about, but let's do it then. So it actually is the case that I am a massive The Lord of the Rings fan. And by massive, I mean that I spent a couple of years building an interactive website with a lot of statistics and maps and like a lot of very, very nerdy stuff that I put online. And it was right when the Hobbit movies were, being released. So of course it got a massive attention. So I guess people who are interested in that will either know who I am already, or they will find out soon enough. But The Lord of the Rings, I mean, that book is of course amazing, but it also got me started in programming, because I started to explore, how to do web things and how to do all kinds of weird creative projects. And that's who I am. The other answer would be The Count of Monte Cristo, which is also super fascinating.
Classic.
Yeah.
Perfect. Awesome. Emil,
what's your favorite book then?
I don't know. I mean, so last year's, like, I'm going to try and do one like every year. So last year I did was more of a business book. I actually got it on my desk here, but it's called Extreme Ownership. It's about leadership and kind of businesses and building teams. So I'll have to read a couple of new books this year. So I'll have to think what it's going to be for end of the year. So
Great. I'll check it out. Thanks.
Awesome. Well, thank you so much for joining the episode today. I'll see you at Form Next. Excited to see what you guys come up with for the demo and the booths and what you're doing. And good luck with everything.
Thanks a lot, Mike.